Hello and welcome to another exciting episode of Beyond the Bot, where we bring you the latest in AI and robotics and how to put it to work in your business today. I'm Tony.
And I'm Steven.
And we're here in the Blue Sky Lab, where we're going to be talking to you today about cobots. Now, Steven, just for our listeners, before we jump into it, can you give us a little bit of insight into what a cobot actually is for folks that might not be familiar with the term?
Well, historically, we've had industrial robots where they worked by themselves in a protected area, and they were very strong, and you had to be very careful around them. Cobots are designed to work alongside people, just like it says. So the cobot concept is that a human and a robot work together, and that allows us for a lot more flexibility in the type of tasks that we can take on.
So, Steven, why might some folks be interested in pursuing a cobot versus an industrial robot? What are some of the benefits and trade-offs?
Yeah. Well, for one, they're less expensive. You can use them in a lot of different places that you can't use an industrial robot. You can also work alongside a human, so that's safer and easier to access and gives us kind of more opportunities for jobs that are maybe tabletop type jobs or repetitive tasks that humans are doing in maybe in an office environment or a lab environment, and it doesn't just have to be on an assembly line.
So with less safety equipment, I imagine the deployment cost might also be significantly lower.
Exactly. So even if the cost of the robot's not lower, the total cost of the whole project tends to be lower because we're not having to do so much hard automation pieces to it.
And without those hard automation pieces, do you get, ancillary benefits around flexibility or?
Yeah, what's really nice is we can program a cobot to do one task today, change its mode, program it to do something else, and it can have multiple things that robot is good at doing, and it can just change based on the business needs of the day.
So cobots are having kind of this big moment right now where their capabilities seem to be growing day by day, and things that we looked at as impossible, 6 or 7 months ago seem to be much more commonplace today. So what's driving that? What's going on here?
Well, one of the things I love about my job is that we get to solve lots of different problems in lots of different industries. And so we're seeing people that are saying, hey, I could use a cobot on an assembly line. I could use a cobot in a warehouse, but I can use a cobot in my office. I can use it in the lab. So we're seeing it being able to do very fine, like we're talking about, 0.1 millimeter repeatability where it's hitting the same spot every time. That's very precise, and that will work for a lot of jobs and a lot of things that historically people have had to do that are actually very difficult for the human hands to accomplish and do. We can have a cobot that can do that. So I think part of the drive is that the cost is coming down significantly, and so more people are seeing a lot more applications of how they can use it.
Now, in terms of just the capabilities, how does AI and kind of sensor technology and cameras fit into this whole equation?
Yeah. So we've had robots since the 1960s, right? And so they've been around for a long time, but typically those robots move from point XYZ to point XYZ, right? And they do the same thing over and over, which is great and helpful. But if we can make them more smart, and this is where AI comes in, where they can detect objects. So using computer vision and machine learning, we're able to say, don't go to point XYZ, go to find this object that is at a particular area, and then we can reduce our margin of error. We can basically say, wherever this is, go ahead and find it. Even if it's moved over a little bit, we'll be able to grab it and move it or do whatever we need to do to manipulate it. And so that AI has reduced the errors and also made it a lot easier to program.
And so I can see if you're not necessarily dependent on a specific, place, maybe that allowing you to work a little bit more collaboratively with humans, because humans, as you can tell from my own desk, right, are not good at necessarily putting things back exactly where they go.
Exactly. So if we think about working in a kitchen, right, you have a cook who's working there, they're not going to put that spatula down in the exact same spot every time, right? That's just not an expectation that humans do. And so if we want to make sure that we're working alongside the humans, we have to have a little bit more margin of error, that we can have a little play and make sure that we can get to the things when we need to, because humans don't always put things in the right spot, or maybe they intend to, but it's off by a couple of millimeters. Well, historically that would have been a problem for a robot, but a vision-enabled robot would be able to adapt to that.
And these vision-enabled robots and these robots that are more broadly equipped with this AI capability, how does that influence how you program them or how you operate them? I know that we build kind of these operator-driven interfaces, and we talk about all the time making these robots easy to use as a power tool. But how does that capability influence the design process?
Yeah, for us at Blue Sky, what we're trying to do is to make it as easy as possible for the end operator. So we don't want you to have a roboticist on staff to be able to use them. So we can leverage AI, we can leverage good software concepts and good user experience or UI concepts to make sure that we are making that tool as easy as possible. So anyone with a basic level of training should be able to use that robot, And then with a little bit more training, they should be able to edit and change and make new missions, as we call them, to be able to like make the robot do the things they want to do. And they can change that day to day, then save all those things. And so as the business changes or that client comes back or goes away, you're able to use that robot when you need it to do that particular task that you programmed, and you didn't have to spend hundreds of thousands of dollars to program it each time for each different client.
So obviously lots of capabilities coming into the robotic space now. And, we've kind of got these three big buckets of robots: the industrial robots, the cobots, and then, humanoids are kind of having this big moment right now as well. How do you choose, which robot is right for your application?
Yeah. Well, I think you really got to think about, what do I need? What's my end goal? You understand that. If that is doing a lot of various tasks that are so different and every day anything could happen in any given moment, then maybe that humanoid robot is the right choice. Because essentially you're creating a humanoid robot. You're trying to think this multitask can do anything robot. That's the point of it. But if we're doing the same thing over and over, or relatively the same concepts, we're moving a box from point A to point B, we're moving a product and placing a product, well, that doesn't need to be a human, because then a humanoid robot is a waste of energy, because you're having to support the weight of what you're moving. You're having to support the weight and balance of that robot. Whereas we can clamp it on a table and save all that energy. That becomes the better use case and use for a cobot in that example. If it's super heavy, then we need an industrial robot, and a humanoid robot may not be the best answer. So all of these are different tools, and we just want to use them to solve the problem at hand and figure out what's the best one for that.
Okay, if we narrow in just a little bit more specifically, because inside of the cobot category, there's tons of options, and it can be a little bit overwhelming. Mm-hmm. How do you kind of decide which ones to pay attention to, which ones might be a good fit, and really the crucial question, how much to spend?
Yeah, so we spend a lot of time working and seeing what are all the options out there. And obviously, UR is probably the first and one of the most popular ones. It has been out for years and years and doing this and doing it well. But now there's been so much competition in the last 3 to 5 years, and even especially the last year. There's a lot of new players in the market, which has brought that price down, and they are making comparable performance robots at a third of the cost of the UR. So we've looked at a lot of different ones, and so we have our favorites, and I think the one we have here is the UFactory Ep.6. It works great for us, and it has a lot of it's easy to work with the interface. It's easy to use the SDK for us to program against, and so that's one that we really like, and it has a pretty good payload. It handles 5 kilos, 10 pounds, has a great repeatability, is very precise, and so for 90% of the applications that we need, this is the right bot for us.
So I guess if I'm a consumer, I'm looking at payload. I'm looking at SDK resources for how I might build software on top of that. Am I also paying attention to the support process, or what does that model look like?
Yeah. So when we work with our clients, we walk them through understanding the whole process, all the things that they are trying to do, and make sure we understand their needs. What is the uptime? What are the number of shifts they're running? All those things. And we factor that into our kind of application process of understanding what they need. Service and support is really important. Do we need 5.9 uptime where it's always up and you're not going to be able to slow this thing down and you got to be able to switch it out very quickly? Then we want to make sure that's part of the design process and finding the right bot that can handle that type of a load. Service and support is something that I think a lot of our clients are looking for, because we're talking about small and medium-sized businesses that can now use a cobot. And so they don't have that roboticist on staff. They don't have that mechanical engineer on staff. And so what we have to do is make sure we have good support tools, both on-site as well as remote, that they can access very quickly and easily, to make it easy so that this thing can work and perform better than what they're currently doing.
So I want to hone in on one thing that you just said, that it's not just a robotics engineering question, that it is also a physical question. Because for most of these solutions, I understand cobots aren't the only thing that you need, right? There's ancillary hardware, there's end effectors, there's rails and movement systems. Tell me a little bit about that piece of the equation.
So your cobot is the base of it, but then you need to add the right software to do the things that you want to do. But you're also going to need to get the right end-of-arm tooling. So think about a drill. Sometimes you put a screwdriver on a drill. Sometimes you put a drill bit on there. This is the same type of thing. And we use lots of different tools for different purposes. So if we're picking up something, we want to pick it up very fast. If it has a flat surface, then a suction might be the best one. So you have suction generators that actually do the lifting. But sometimes we want more of a traditional claw, like you can see in one of these right here. So this is a claw one that comes with the robot. You can add this real quickly. It's very easy to use. It turns on and off, opens, closes to the millimeters you want. So that works for a lot of universal tasks. But what we tend to see a lot of times is we need to create a custom end effector that works for a very specific specific purpose. So in this case, this one can like push and is fairly firm on the end, and we can move and manipulate things that way, but it's also soft enough in the middle that we could squeeze and pick up an egg without actually having to break, we wouldn't break the egg. And so we can make these custom things. So sometimes it's 3D printed, sometimes we're working with a fabricator, but we're creating the right end effect or the right tool for the job. Now, we talk about suction and pickup, but it also could be an application, an applicator. So like the one behind us here is a spray bot that does kind of lots of different professional coatings, and so we can do adhesives or paint, and so the arm is the base of it, but what we put on the end is what makes it a valuable tool.
So there's clearly a lot to this equation when it comes to, kind of leveraging this technology to solve this problem. For small business folks, that are kind of interested in getting into this and looking to leverage some of these solutions, who's their ideal partner? Is it the robotics manufacturer? Is it the end effector provider? Who kind of ties this all together and is the quarterback of the play?
Yeah. Most people we see are working with integrators. And I think an integrator is someone you're going to need in most cases because the manufacturer provides the robot. It has a basic level of support, but most people need some type of customization, either through the software or through the end effector. And so you need someone with experience that helps you solve that problem, especially the first time and during that setup. Now, for us, we use a lot of software that allows us to set it up the first time and then let you go and build and make new missions and things afterwards. It makes it much more flexible, so you're not dependent upon us, but you can always reference us when we're needed, right? And so I think most clients who are going into this place, they maybe talk to the manufacturer, but they ultimately end up going with a third party that helps them to kind of make and get the full solution, not just an arm to solve their problem.
Wow, that's interesting. So as we look to the future with more and more of these actually in the workforce, being productive, we often talk about like managers for people, but what's the corollary for a robot? Who oversees it?
Yeah, it was interesting. We were talking to a client the other day. We were talking about HR and human resources. Like we have RR, right? Robotic resources, right? I don't know what we're going to call it, but ultimately it's people who have a basic level of training who can make sure that the robots are doing the job they want. And so sometimes that might be just using a user interface and be as simple as just kind of working in a web browser to edit and change and update and make new missions for new products or new concepts and new task that you want the robot to do. And then sometimes it might be, okay, we need somebody who has a screwdriver who can disconnect 2 cables, take out 6 screws and replace the arm and then ship it back. So you need a little bit of that kind of like on-site level support. And so is that going to be a robotics resources department? I think you'll start to see companies move a little bit in that direction where, where you might have had 100% of your resources might have been all human. Now you might see a flow of maybe 20% and then growing and flowing with the business as it's changing and as automation gets better.
So that's an interesting integration problem because it's not just about building the robot for the solution, but figuring out how to get it to, really be in a collaborative relationship with its coworkers, right? And so, what does that look like? Do you give them names or, put googly eyes on them?
So, human-computer interaction is something that's very important to us, right? We want to make sure that how you interact with the robot, you feel comfortable with it, both in a safety perspective, as well as also like this is a coworker. It's a cobot. It's doing something with you. So we sometimes have, had googly eyes on them. We give them names, and so it just kind of depends on the business and the industry and how creative we want those names to be. But we don't just number them. We're very clear that we want them to have very specific names, and I think that's important to working alongside of them. But also, we want to make sure that the communication process with our clients is clear. And we've been through this with clients before, and things might not have been the best way to release that information, and so people got scared. People were fearful of it when they didn't actually understand what was really coming. So we also work with our clients to make sure that communication process with their current employees, that they understand what the Cobot's actually going to be doing, not what they fear their employees might fear it might do.
Wow, so the future really is kind of this man plus machine, not man versus machine dichotomy.
Exactly. I think, in most cases, we're talking about these cobots come in and work alongside the humans, and then people repurpose those humans to do a different tasks. I think almost all of our clients we've seen do that. And so some of them have even opened up new businesses and new opportunities because they could put those people into new places. And so it's not really replacing them. It's just kind of repurposing and moving and doing different roles.
Well, Stephen, certainly exciting to catch up with you about the ever-changing world of robotics and artificial intelligence. And we're grateful to you for joining us on this exciting episode of Beyond the Bot. Keep following us. We'll be back next week with another exciting topic. Thanks for joining us.